So I'll continue with part three of the physics. As you can see, I've already actually solved or explained some things, but the audio didn't uh, get captured. So let's just continue. So we have, well, starting with, we're trying to explain speed. So speed is distance all over time. Now, I explained that there's like an easy method to memorize formulas. So imagine we don't know the value of, this is what I did. We drew a triangle. We have the up and the down like this. So this is speed, this is distance, and this is time. So if we don't know what speed is and we need to know the formula, we can just cover it. Imagine that this green highlighter I'm about to put on the speed is your finger. So you cover it because speed is unknown, but you don't remember that speed is equal to distance over time. You don't remember that formula. You can simply say cover the S and then you're left with what distance up, time down. So the formula is going to be S is equal to distance all over time. Okay. Now, what if instead of speed being missing, we don't know what, we are not given time and we don't remember what the formula is? So imagine this red highlighter is your finger. So you cover it. Just imagine I've cleaned up this S because I can't clean it off right now. It will scatter the structure. So the formula for time is going to be distance over speed because we're left with what distance and speed and they are up and down. Okay. So we have time is equal to distance over speed, like this over here. Forgive my handwriting. Now imagine that instead of it being speed or time that is missing, it's instead distance that we have to be missing. So how do we solve this? Well, let's put s and t down. So we're just going to put like a times here. And we're going to have distance to be equal to what? S times t. I wonder if this method of remembering formulas is clear. You can use it with any formula actually that is just like three that has the same structure as the speed. For example, velocity, you can use this triangle method of remembering formulas. It will work, okay? So it's not just speed that it works for. High, high. So now let's actually move on to velocity. So velocity, its formula looks like this, d over t. But it's different because the d in speed stands for distance, and distance just has magnitude, it doesn't have direction. While displacement, on the other hand, has magnitude and direction. So velocity is displacement all over time. Okay, you can use the triangle method previously to know the formulas. So I won't do it here. Just try to learn how to do it yourselves. Now let's take one little example. So imagine that we have a car that travels at an average speed of 100 kilometer per hour. Let's see, speed, speed equals 100 kilometer per hour. Oh no, not speed. Yes, speed, yes. 100 kilometer per hour. So you can see the power has a minus one because it looks like this actually. Remember rate, right? Kilometer all over hour. If you want to write it in the normal format, it will look like this. The h will have a negative one. I think we'll treat that in maths too, so you understand why that happens. So we have the time to be equals to what? 5 minutes. Time 5 minutes. But we don't know what the distance is. We're asked to find the distance. So you can try to use the triangle method to actually remember what the formula for distance is. But I just want to make this video quick, so I'll just say distance is equals to s times t. So that's just going to be 100 times t, times 5. So that's going to be just going to be 100 multiplied by 5. That will give you 500. But you can also remember, if you want to actually be sure of what the unit of distance is, because you must always include the units, okay? You can actually include it when you're multiplying. Remember, d is equals to s times t. So what's s? 100 kilometer per hour. So we write it as 100 kilometer per hour. We're going to put the h here. Oh, I've forgotten one important thing. Sorry. So just forget this. So then we have the time. We're going to multiply it by the time. But the time is in minutes, right? 5 minutes. But the speed was given in kilometer per hour. So what do we actually do? We need to convert these minutes to seconds. Sorry, to hour. So remember the that little tune we used to make in primary school that goes something like 60 seconds make 1 minute. 60 seconds make 1 minute. 60 minutes. 60 minutes. 60 minutes make 1 hour. So how do we actually uh, convert this from minutes to hours? So it's going to be 5 minutes all over 60. So let me clean off this minutes here because this 5 over 60 now makes it hours. Okay, so it's no longer 5 minutes, 5 over 60 now makes it in when you divide it to give you in hours. So let me just clear off this HRS to match the each here. So let me use a different color of pen. So when we cancel the each, we're left with what kilometer because there's no kilometer to cancel it with. So that will mean our final answer of the distance will be in the unit of kilometer. So let's solve this. So 0 will cancel 0. So we're left with 10, 5, and 6. So that will give you 10 times 5 all over 6. And if we press our calculator, our final answer is going to be 8.3 kilometer. Don't forget the kilometer, you can write it here too. Yeah, 8.3 kilometer. I believe this is explanative. So let's move on. 5. So now let's actually look at the distance or displacement time graph. Let me write that down here. Distance or displacement time graph. That slash there means or, not over. I'll just get that off. It's bigger so you guys can see it. Let me use my favorite font poppins. Okay, so let's take a look at the distance or displacement time graph. So it looks a lot like this. Then you can have so on this side of the graph we have distance, or displacement, and down here we have the time. So let me just actually explain what instantaneous velocity is. Oh, let me see if I can find like May I explain what's instantaneous velocity is? There's just the velocity at any instant of time. So the velocity at a point at, let's say, at this point here.
And just as a side note, we
This
are
is
still
the
going to treat
instantaneous
instantaneous
velocity.
velocity in another video.
Fairly simple. And acceleration is the rate of change of velocity with time. So let me clean this off because this is distance time graph. So we have like acceleration to be equal to velocity all over time. And this is another formula you can use with that triangle method to remember formulas. So acceleration is also the final velocity minus the initial velocity all over what? Time. Now we can also have velocity time graph in which our final answer would be what's acceleration. Okay? The acceleration is the gradient. Let me actually show you how the velocity time graph looks like. So it's like this. At this point you will have velocity and here you're going to have the time. So you can have something like this. It's supposed to be a dash time, sorry. So the gradient of this would be acceleration. You know, acceleration is change in velocity all over the time. So now let's say we're asked to calculate the time of a graph that looks like this. So I will actually prefer to jump back into our desktop. My bad. So, because this is a fairly long question, but it's necessary. So we have something like a car starting from a from rest accelerates uniformly and attains a speed of 80 meter per second in 30 seconds. It maintains this steady speed for another 30 seconds. It then slows down uniformly, until it comes to rest in the next 40 seconds. So the first one is sketch the velocity time graph for the motion of the car, and from the graph determine the total time of travel? So this is a very long question. So let's try to solve it together. So this is the question up here. Now let's try to solve it together using our marker. So the car, we have a car that starts from rest. Starts from rest. So let me draw. Let me use this actually. Okay. So he starts from rest. And starting from rest means he starts from zero. So zero. And he accelerates uniform. That is, he accelerates with the like with his it's not like it's all over the place acceleration. It's not like it's space, it goes down, space, it goes down. It's accelerating at a pace. So he attains a speed of 80 meters per second. That means let me remember this side is the velocity. So whenever you're drawing a graph, you write it here, velocity, especially in physics. Then there are also graphs in math. You know what? Let me clean this off and use a text bar. This is velocity in meters per second. Let's just draw it closer here. And you must include the arrow that is like pointing upwards. Then we have arrow here, like that. Now let's also draw or write the text down here for time. That is in seconds, like that. So he attains a speed of what? 80 meter per second in 30 seconds. So let's like draw our lines of the velocity. So we have 20 here. Then you have to choose an appropriate scale. So we're going to use 2020s. So we have 40, 60, sorry, not 70, 80, and let's see 100. Let's go further. So let's see up here is 120. And let's do the same for our time. So for the time, we're going to just be using tens. So here is 10. Sixty, 80. Just for how slow it is. 90. Let's say 100. Okay, so let's look at where we stopped again. So he attains a speed of 80 meters per second in 30 seconds. So I'm going to draw a line that stops this. This is 80, right? This is 80. This is 80. And then 30 is around here. So this is 30, I believe. So let me actually see. Let me just draw it. Line. I'm going to draw a line that shows this is 30. And this is 80. So I'm going to draw a line to this point here. From rest. Remember, he starts from rest. So it's not that you're going to start from 20 to 80, okay? So it starts from rest. Just forgive all this delay, please. So we're going to clean it up. Oh, my bad. This one we need to clean. Okay, so we've reached point 30 from 80. It says 80 meters per second. So that is 80 meters per second. Now we're going to draw a dashed line to till 30, like that. Let me take eraser again just to clean up the spots. Okay, so afterwards he maintains this speed for another 30 seconds. So it's not like he went from here and then jog for another 30 seconds. No, he said he maintains the speed for 30 seconds. So another 30 seconds. So that's from 30, 40, 50, 60. So that's 30 seconds. 30 plus 30 will give you 60. So I'm going to stop at point 60, which is around here. So I'm going to draw a line that connects that. Then we're going to clean this off. So it maintains the speed for 30 seconds. Now it then slows down uniformly until it comes to rest in the next 40 seconds. So before that, let me actually draw dashed lines too. Oh, this is 60. So let's clean off this part. Okay, now let's let's actually look at the last part. It then says it slows down uniformly until it comes to rest in the next 40 seconds. So that means he slowed down until he reached rest. So not rest, it didn't go back like this. Rest is basically just this line. So it came back to rest down in the next 40 seconds. And 40 seconds, 40 plus 6 is what, 100. So that means it stopped here. So let's draw the line from here to here. This is where it stops. So that's how the line looks like. So this is our complete graph, complete image. Now let's actually solve this question. Let me clean up this. So let's solve the total time of travel is basically 100. Why? Because we went from 0 to 30, 30 to 60, 60 to 100. So 0 to 30 will give you 30. You add the next 30 seconds is spent again, 30. Then you add the final 40 seconds is spent again, which is what? 100. Now, let's say we're asked to solve the acceleration in both parts of his journey. So that is in this part, this is part 1, and in the second part 2. So, what would be the solution? That's actually pretty simple. So, remember that solution is change in velocity over time. So he went from, because let me write the formula down. So A is equal to V minus U t minus u all over the time. And what's v final velocity? What's u initial velocity? So what was his initial velocity in the first uh, part of his journey? Zero, right? Because that was his first. That was the first velocity he was given in his first part, which is what, zero. So his initial velocity is what, zero. Okay, it's change in velocity over change in time. So that means we can also have like t2 minus t1. So what was his final velocity in the first half? It's what's 80. So we're going to have 80 minus 0. Now what about his time? The first time he was having 0 2, because this 0 is for up here, 0 is for this side too. So his initial time was what? 0. So we're going to put 0. And what was his final time? Because it's 30 seconds. So 30 minus 0. So in the first segment, or in the first part of his journey, or first half of his journey, his acceleration was 80 over 30, which we can simplify to be 8 over 3. And if we were to divide this using our calculator, we're going to have 2.67 meters per second. Now let's take a look at what his second part of the journey would look like. So we're using the same formula, final velocity minus initial velocity, final time minus initial time. So what was his initial velocity in the second half? It's 80 now, this part. It's 80. It's no longer 0. The 0 was in the first part. Now the second part is going to be what? 80. So let's clean up our solution for the first half. Okay. So in the second half is is oh